And in order to do that, we're going to look at the graph on the graphing calculator. On the calculator screen, you'll note that for the same value of x, I'm given 2 points, one right under the other one. We had noticed this earlier when we had graphed the function g. Next, let's see how we can look at a graph and tell whether or not it's a function. In order to do that, we're going to look at something called the vertical line test. The vertical line test states if each vertical line intersects a graph in no more than 1 point, the graph is the graph of a function. Let's look at our 2 previous examples where we had graphs and see which ones end up being functions. In the example that we worked, which looked like this, notice that if I draw a vertical line through this graph, any vertical line at all, it will hit the graph in at most 1 point. This depicts a function. In the example that you worked on, we noticed that if I draw a vertical line, in fact there are many vertical lines that would hit the graph in more than 1 point. And for this reason, this is not considered a function. Next, let's look algebraically at how we can write down function values. In using function notation, we can give the name of the function as f with parentheses around x, read f of x. This does not mean multiplication, it's just notational. This f of x value equals y. And what it means is that we're giving this function in terms of the independent variable. In this example, we want to define y equal to f of x as 3 plus 2x. Next, we're going to look at how we can use this notation. In our example, f of x equals 3 plus 2x. I can then ask you to evaluate the function at the x value of 1 by just writing down f of 1. We then evaluate this by putting in the value of 1 in place of the independent variable x. So we get 3 plus 2 times 1, which is a value of 5. This means that when the x value is 1, the y value is 5. Likewise, let's evaluate f of 5. This would equal 3 plus 2 times 5. That's 3 plus 10, which gives us a value of 13. And finally, f of negative 4, 3 plus 2 times negative 4. That's 3 plus a negative 8, which gives us a value of negative 5. Now, let's see how the graphing calculator also can evaluate the same things we just did by hand. We're going to put into our graphing calculator, in our y equals key, the value of the function that we just came up with, 3 plus 2x. In doing so, what we are doing is exactly the same notation. Of course, we don't see f of x here. Now, if we want the graphing calculator to evaluate that function at a particular value, then what we can do is quit this screen, go back to our home screen. We can use our vars menu, which stands for variables. What we want is a y variable, we want it to be a function, and we want y1. When I press enter, it brings y1 up into the home screen. Then we can put parentheses, and the first thing we want to evaluate is y of 1, or f of 1, and we end up with our value 5. Repeating, let's do this value, this function evaluated at 5. We can press vars, y vars, function, and we want y sub 1, and evaluate that at the value of 5 to give us the value of 13 that we had had previously. The next thing that we want to look at is perhaps the table and how we could use this also in order to give us our values for a particular function. Let's go back to our graph, and we have y equaled 3 plus 2x. I'm going to go to table set, which notice is above the window key, and we'll press table set. We want to start our table. Here, this table start is at 0, and the change in the table is 1. This is pretty much the standard way we do this. To get to the table, we press second graph, and we have now all the table of values that are given for this particular function. For instance, you'll note 1, 5 is here on the table. The value 5, 13 is also here. If we wanted to see the value at negative 1 or negative 4, what we could do would be to scroll upward, and here our value of negative 4, negative 5 is shown on the table of values also. The next thing that we want to do is to let you try a function on your own, trying this on your calculator. So let's look at two different functions. Well, I'm going to ask you to put the first one into y sub 1, the second one into y sub 2, and then evaluate different function values for each of these. Try that now. Now, in doing so on the calculator, you've probably used all the function keys. Let's just make sure by doing this also by hand that you understand how to use function notation. So let's begin with y sub 1 equals 3x minus 7, and you were asked to evaluate y sub 1 equaled 9. So by hand, what you would do is to substitute in the value of 9 wherever the x was. You have 3 times 9 is 27. 27 minus 7 is 20. Y sub 2 we can do by hand by substituting in a value of negative 2 wherever x is in my function. That's negative 2 squared plus 4 times negative 2 plus 6. This gives us negative 2 squared is 4. 4 times negative 2 is negative 8 plus 6. And we get negative 4 plus 6, which gives us a value of 2. We can also check this on the graphing calculator, and let's do that now. If we look at y equals, you should have put into this the function 3x minus 7, and into y sub 2 we have x squared plus 4x plus 6. Next, we're going to go back to our home screen by doing second quit. I'm going to clear it out. We want to evaluate y sub 1. And we're evaluating that at the number 9. And we get the value of 20 that we'd gotten by hand. We next want to evaluate y sub 2. I can press number 2, or I can scroll down and highlight y sub 2. And I'm evaluating that at the value negative 2 to get our value of 2. The last thing that we want to consider is how to use the stat function on the calculator. And so to do so, we're going to look at two lists of numbers. Here we have list 1, 0, 6, 2, 9, 4, 12, 6, 15 as list 1 and list 2. These are our points. We're going to put these values into the calculator now. It's nice to know how to put these in the calculator. We can go to our stat key and insert values in for list 1 and list 2. We'll put in the values 0, and notice that the highlighting goes down, 2, 4, 6, and then scroll back up and over to list 2, 6, 9, 12, and 15. Now, looking at this set of values, we can ask certain questions. For instance, if I define this as list 1 is going to be the set of x values and list 2 will be the set of y values, then I ask you that I tell you this is a function called g, then what would be g of 6? That would be the value that I get back for y when my x value is 6, so the answer would be 15. If, on the other hand, I asked you for what value of x does this function equal 6, you would be looking at the top point, where I get the value of 6 whenever I'm inserting the value of x equal to 0. As our final example, we want to look at an illustration of how to use the f of x function in a different format. If we're given f of x equal to x squared and asked to find f of x plus h minus f of x, then what this means is to take the value of x plus h and perform the function on that value. Or in other words, f of x squares a number. So here we want to take x plus h and square it. Then we want to subtract off f of x, which is just x squared. Let's evaluate that by multiplying out here. Recall that x plus h squared means x plus h multiplied times itself, and then subtract x squared. Multiplying x times x gives us x squared. X times h gives us xh. H times x gives us another xh, and then h squared minus x squared. Combining like terms, we note that my x squared subtract out. We can then combine the xh with the other xh to give us 2xh, and our result is the expression 2xh plus h squared. The concepts of relation and function are central to many of the topics that we cover in algebra. You need to spend some time making sure that you are familiar with these concepts, that you're familiar with the notation, and you can do that by working some exercises from your text now.